Okay, so Alyssa plays soccer and baseball. So that's probably hint, hint. Those are the two things that are going to become our variables. So soccer and baseball. This is on page 11. She burns 400 calories an hour playing soccer, 50 calories an hour playing baseball. Each week she's willing to spend at most 18 hours exercising and wishes to burn at least 4,000 calories. Okay, and this is a wide open question, no guidance whatsoever. It just says draw a graph to show the time Alyssa could spend on each activity in 1 week. Is basically another way of saying is graph the solution set, right? And it's basically showing all possible solutions. So when you graph it, you're basically telling your audience these are all possible combinations you could use to meet all the requirements that are present, all the restrictions. I know we're sick and tired of restrictions, but there's inequalities here, right? So let's write our inequalities here. So you basically go through the steps. If there's no guidance, you need to define your variables. And so we will let x be, let's for instance just say you're saying this is soccer and baseball. Let's say it's like that's all I've got right now. I'm kind of stuck. I'm going to add something later on here. And I will immediately go ahead and just say, even if it's baseball and soccer, I can't have negatives. Okay. At most 18 hours, right? This statement right here should tell you, right, that there's an inequality behind that. And so it's 18 hours exercising. So doesn't that imply both sports, right? It's not saying just baseball or just soccer. It's just saying 18 hours combined. I will write that down. You should see or you should read that this is a combined situation. So let's see if this works. X plus y at most, right? You'd have to say that this is less than 18 hours. So if you read this statement, wouldn't it only make sense that X and Y represent the number of hours at each sport? Would you agree? So let's go back here and just add that. I'm okay if you do this, right? If you just add hours, then we're all good, okay? Now you've been very specific in your definition. You realize that after writing your first inequality that it had to be hours. Next, burn at least 4,000 calories. Burn at least 4,000 calories. Again, it's not saying during which sport, right? It's just saying burn 4,000. So there's, again, an indication of combined. So calories, let's go up. We are given the calories burned at each sport. So I'm just going to make sure it's playing soccer. Soccer is X. Here we go. 400X plus 50 calories at baseball. I guess baseball, what's that? Were you saying something? Okay. Is greater than or equal to 4,000. There we go. So are there any more inequalities? I don't see a single at least or should be or there's a capacity, nothing like that, right? So this is it. There's only two inequalities here. Inequality number one, Easy peasy. These ones are easy to graph. You'll see that in a bit. X and Y and a number. The intercepts would be 18, 0, 0, 18. Boom, you've got them. These ones are a little bit more challenging, but you have a calculator, so what am I saying, right? It shouldn't be a problem at all. Okay. So that's that. I'm going to leave it there for now. Okay. Or let's graph a 2 first, and then we're going to go big, right? So let's just do this one for now. And you don't have to, other than just following along, you don't have to write down the question or anything like that. So let's go ahead and do that. I will graph here. And before I graph, I will come up with the intercepts. So it's just 18, 0, 0, 18. I will not even show my work other than just stating the obvious, right? And I will just rewrite it. X comes over negative. And you say, hey, that's what I need. This is a solid line. The true region would be below. We will shade above because this is a system. So we're doing reverse shading. Next, right beside it, I'm going to work with, you know what? I want to keep this section for the graph. So I'm going to do this underneath, okay? I'm going to underneath write down the other one, 400x plus 50y. So let's go ahead and find this. This one I do want you to show work because it's dangerous to just try to do this in your head, right? One sign and you're off, right? So 400x, let me zoom into that because I'm going to stick to that area. Okay, 400x is equal to 4,000. Not always will it be whole numbers. Sometimes it'll be decimals. Not a problem. So that'd be 10, right? 10, 0. And on the other side, you have 50y is equal to 4,000. What are we doing here again? Just to remind you, we are finding the intercepts of the boundary line. So for a little bit, we're forgetting about the inequality when we're working in here. We're just focusing on the line. You can cancel the trailing zeros. 5 goes into 48 times, so it would be going into 480 times, right? So you have your intercepts. This is it. Two inequalities, we're done in terms of intercepts. So now we're just going to go 50y is greater than, make sure the sign is the correct way. I'm bringing the 400x over negative, and I'm tacking the 4,000 right on. Divide everything by 50. No negatives, okay, so this goes in there exactly 8 times. So it'll be negative 8x plus 80. Solid, true is above. I will shade below. I hope that helps you, the little 3-letter thing. To me, it makes a big difference when you're ready to graph. You don't have to think anymore. You just like, I determined that already when I was working on that particular inequality. So you're not mixing it up, right? So we have that. Let's go and graph now. Okay. Where's my ruler here? Okay. So these ones are actually easier to graph without a grid, if you ask me. It's a word problem, quadrant 1. Just make one of those, right? L, backwards, I guess. Arrowheads, I will say right away, soccer and hours, and baseball and hours. Soccer hours, baseball hours. And you look at your intercepts. That's key here. You got to make sure they all fit. So I'm looking at 18 here, and I'm looking at 10 down here. So if I go to 20, I'm good. So I'm going to go 5, 10, 15, 20. Beautiful, right? Stretch it out. Make it fit your graph, right? And then I look at my y-intercepts, 18 and 80. Oops, right? So you got to make sure you fit the 80. So I'm going to be a little bit more conservative. So I'm going to go 10, 20, 30, 40, 50, 60, 70, 80. That works. So I'm going to label every other one. Just make sure if you run out of room, either erase and extend or pick a different scale. Go up by 30, something like that. Okay, I'm good. My scale is good. So let's graph. 18.0 is right about there. 0.18 is right about there. Sometimes I wait to label the lines. Other times, if it's only 2, I wait because I don't want to cut off my graph. Okay, so 10.0 is right about there, and 0.80 is way up here. And I think what I want to say is, don't be fixated on the solution region being a certain way. It changes completely. It doesn't. It all depends on the wording of the problem. Okay. All right. So I think I can label the. I can go y is greater than or equal to negative 8x plus 80. And this one is just x plus y is less than or equal to 18. So it doesn't matter which label you use, which version of it, the rewritten one or the original. And I'm going to my first line. And that one I'm going to shade above. Really? Whew, you scared me. Don't scare me. Anyways. All right, so that's gone. False is shaded. The second line, I'm shading below. So there I have to go and just shade below the line, right? Okay, so that leaves us with this triangle here, which I want you to always label as that's my solution region. Especially because we're using reverse shading, we need to make sure we indicate this is where the solution is. And POIs, right? Never forget about them. So we're going to go ahead and do that. In this case, we have 3. You can read these right off the graph. So 10-0 and 18-0. Most of the time you'll have at least a couple that you can just read off the graph. You don't have to, right? Because you already did the work. You know exactly where these points are. So read, read. And this last one is going to be worth more on a test or a quiz because you need to use your calculator for it. So we're going to figure out what that is now. So grab your calculator and let's go to y equals. You almost forgot about this, right? This part. Clear, clear, clear. Plot 1 is off. I'm going to go negative x plus 18 and then negative 8x plus 80. I'm going to go graph, even though I know it's not going to work for me. Well, it might actually. It might. Not barely. You can see somewhat that they're meeting right there, but I don't recommend that. So I'm going to go to my window. I don't need negative 10x, right? So I'm just going to go like negative 2 or something, just a little bit past into the negatives. My x max, if you look at your graph, I'm going to go to like 20 for my x max. X min, just negative 2 will do. X max, I'm going to go to 80 or 100. I'm going to go 100. I want to see a little bit past the highest point there. And once you have that, you can go ahead and graph. You should see it actually looks almost exactly like ours because we're using the window, the same window as we have here, right? So sometimes it looks different just because your parameters are different. So don't fall for that. It's not necessarily wrong. So second trace 5, you only have 2 lines, so you don't even need to think. Just enter, enter, enter. And here is the 8.86, comma, 9.14. Okay, 9.14. This is the calculator. You don't have to tell me that on the test, by the way, or any assessment. You don't have to tell me this. This is just for you. And then you have to ask yourself, what kind of data, what kind of data is this? And it's hours, so it's continuous. Unless the problem says you can't do partial hours, we always assume it's okay. So I will make a note here. Data is continuous. Therefore, no rounding, right? No rounding necessary. Okay, so if it had been discrete, we would have to deal with this decimal here. We'd have to round it to a whole number. And quite often it is the case. More often than not, you're going to have to round. A possible solution. So you can just pick, you can say 15 and 1, or you can say 10-0 would actually work, right? 10-0 is it's a solid line. 11-1, right? I'm just going to say example 11-1, right? Playing soccer for 11 hours and baseball for 1 hour will work, okay? Or is a solution or something like that. I just want you to know that that point is actually now referring to a specific variable. So this is basically, for now, I will stop there And then later on, we will find the best solution. Right now, we're just stating a possible solution. Soon, we're going to narrow it down to there's one solution that's the best based on the word problem. So, I will let you do this one on your own, but I will first come up with the inequality. So let's go to 12. I'd rather spend more time helping you decipher the inequalities than the graphing. But I will do one more graph. I'll pick the hardest that I can think of, and I'll graph that one. So anything else, you will be like piece of cake, right? Some of you don't like cake, so whatever. Piece of pie or apple. There you go. So this is on 12, page 12, okay? The owner of a pet store wishes to buy at least 8 cats and 8 dogs. So at least 8 cats, and it's basically saying and at least 8 dogs. So it's specific to each variable. So we'll go inequality here, inequality there. They're two separate. It's not saying wishes to buy 8 pets combined, right? It doesn't say that. It says specifically 8 cats and 8 dogs from a particular breeder. Cats cost $25 and dogs 75 each. Yeah, right. This is old, obviously. How about $1,000 or more for a puppy? The store owner does not want to spend more than $1,500. Okay. Not spend more. So it's basically will spend no more than $1,500. So it's just worded a little differently, but you should still be able to identify that that is an inequality right there. It's not just a fact. There's a limitation to it, right? You can't spend more than that. Draw and determine the number of animals the owner can purchase. So it's basically draw the solution set. So, sorry, I'm just going to fold this page because it keeps on dragging me down. There you go. So we'll let x be something, y be something. It's probably x would be number of cats and y would be dogs, right? And you can just say number of. So it's actually talking about the number of cats and the number of dogs. We can't have negative of them. So just do that every time. Don't have to guess. You can't go wrong by adding this, right? You can't go wrong. So even if it's not asking, just put it down. So the first inequality here is specifically to the number of cats. So that has to be at least 8. The number of dogs has to be at least 8. It doesn't work if you say x plus y has to be greater than or equal to 16. That's what a lot of students want to combine them. If it's specifically to each, keep them separate. And then we're talking about the cost here. I'm going to put that here. 25 for a cat and 75 for a dog. And that combination has to be less than or equal to 1,500. And so there you have your 3 inequalities. However, these two are extremely simple, easy to graph, right? Vertical line, horizontal line. You like these. If they show up, they make your lives a lot easier. I will leave the graphing to you here. I just wanted to make sure you had your inequalities before you graph. Now, this is going to take a little bit longer, this one, and I'm going to ask you to graph with me. So we're going back to that handout I gave you. And by the time we're done today, you're going to have the key, the complete key with all the graphs, everything for you to check if you're practicing this evening or wherever, whenever, tomorrow morning. I want you to do that. And so let's go back to that handout. And I hope you have it as part of your notes. And the one I want to graph with you that I think is the hardest is question 3. Yes, that's the hardest one. This one here with the pulled pork sandwiches and the hot dog. So I'm going to grab a piece of loose leaf and use that question. And I really encourage you to keep that together. Keep the handout with this piece of loose leaf in order so you don't misplace it. And basically what I'm going to do is I'm going to write down those inequalities right off the bat. So this is question 3. I'm going to write down 1.25 x plus 0.5 y is less than or equal to 750. We determined that already yesterday, so we'll just go ahead and do that. Let's find the intercepts for this guy. So this is the most work you'll ever have to do for a question. This one right here. So $1.25 x is equal to 750, right? The nice thing is there are very few negatives, if at all. Okay, so 600. What? Yep. I warned you about that, right? That the numbers are going to get bigger, but no big deal. We're just going to adjust our scale. Then it's 0.5y is equal to 750. And that's 1500. No big deal. Box that in. I always like to keep that separate from everything else. And then rewrite 0.5. I'm dropping the 0 after the 5 because it's irrelevant, right? It's less than or equal to negative 1.25x plus 750. Divide everything by 0.5. And sometimes I encourage you to try it. 1.25 divided by 0.5 is 2.5, right? It's a finite. You can leave it as is, but it sometimes makes it easier to just divide them out, and it's negative. 750 divided by 0.5, I already know is 1500. Box that into SU. Solid, true is below. We will shade above the line. Let's do the next one. I'm going to cut that right here. The next one is the one we really like. These ones are a freebie, and you just have to rewrite it. Solid, true is below, right? We will shade above. And just look at the way it's pointing. Confirm with the neighbor, right? They both are pointing the same way and you're shading the same region. So it tells you you're doing things, right? It's lining up. Either you're doing them both wrong or both right, but at least you're consistent. I'm going to block this here just because I like to keep them separate. the next one, I'm going to need a little bit more room for the next one. So I'm going to deal with this one here. X is greater than, sorry, I'm going to do that underneath to use up this space here. X is greater than or equal to 2y. This might be a little more work for you, perhaps. I hope I'm not going to confuse you with what I'm about to do here, but I'm going to put the 2y over. I want to make sure I don't throw you guys off. I'm just going to stick with what I've been showing you. 2y goes over negative, and the x comes over negative, right? You're basically, they each are going to the other side, which means they both change sides. You divide both sides by -2. Warning, right? What happens to the inequality? It flips. And so this is 1/2 positive x. That's kind of how we write it. And so this is solid. True is below. We shade above. And this one is a bit of a, I should say, pain, right? Yeah. Francis, you had a question? Yeah, okay. This is the one you need to watch out for. You need a second point. I don't know if you remember, but if you don't have a, if it doesn't have an intercept, this is 0 by the way, then everything is 0, 0. You don't have that second point to connect to. So you need to do that. Second point, right? I will let x be what? What should we let x equal to? Some of you are going to say 2, right? Yes, it's correct. But look at the numbers. We're in the hundreds and in the thousands, right? I'm going to suggest pick 200. At least something a little bit bigger than just, because otherwise it's going to be a small number. It's going to be hard to fit on your grid. Okay, when you have that scale so big, it's like, well, where is 1, right? Where does it go? So if it's a couple hundred, it's better. So y is 1/2 times 200. And what's half of 200? 100, right? So 200, 100. You just found that y is 100 when x is equal to 200. So this is your second point. You need to do that. So what's your first point? It's 0, 0, right? Your y-intercept is 0. This is your second point. And yeah, that's going to make you scratch your head a bit, but it's just finding another point. You could pick any value for x. I just pick a smart number, okay? All right. Last one. Let me get this right here. That one was 250 x plus 150 y. Francis, did that answer your question? Okay, right. Sorry, I'm gonna go over. X-intercept, y-intercept. What's my time at? I'm good. Okay. 2.5x is equal to 1,000. 25 goes into 104 times. So 2.5. I want to say 400. I'm going to say 400, but I'm not sure. So I'm just going to double check. Yeah, it's 400. That's why I don't teach pre-cal, because my mental math is, I'm not willing to risk it. Anyways, 1.5y is equal to 1,000. And this is going to give me a decimal. No big deal. That's a lot of work, right? Yeah, I hear you. Just for a graph, just to figure out how many sandwiches or hot dogs to sell, right? Anyways, 1.5y is greater than or equal to negative 2.5x plus 1,000. And here, I'm going to try this. Negative 2.5 divided by 1.5. That's kind of, that will be a problem when we want to graph it. So I'm just going to keep it that way. I know it's kind of ugly, but I'm going to leave it like that. Instead of reducing it, some of you like to use that math function, reducing a fraction, go for it. And I'm also going to keep this one like that because I'm going to enter this into my calculator. And that should not scare you because, you know, I'm just going to plug that in. It's not like I'm going to have to worry about the fraction. Solid, true is above because it's greater than. We will shade below. I'm going to let you copy that, make sure you have that. And now I'm going to start, before I graph, I enter this into my calculator. When it's this many lines, I kind of want to know what am I up against. So let's go ahead and do that in no particular order, but maybe let's do them. You technically can do it in whichever order, but I'm going to start with this one. Negative 2.5x plus 1500. Make sure you include the variable x, otherwise it's not going to be a diagonal line. Plus 650. And then I'm entering this one here, the 1/2 x. I always use brackets when I enter fractions, just to be safe. Right, so those are the first three. And then the last one, I use negative 2.5 divided by 1.5, close that bracket, x plus bracket again, 1,000 divided by 1.5, close bracket. So I know it looks daunting, right? But it really just is, just type it in the way you see it. And then you don't have to worry about rounding or anything like that. So let's go ahead and graph this. I'm not seeing anything. Oh, I saw one just there. And so it has to do with your window. So you kind of have to look at your x-intercepts. We have 600, 650, 400. So I'm going to go with 700 as my x max. So let's go to our window. I'm going to go 700 there. And then I'm going to go to y max. I'm going to keep my y min and x min the same. What's the highest y value here? 1500, 650, 666, 1500. So if I go to like 1700 for my y max, that'll do. Do you understand that part? Right? And graph. There we go. One there, one there, one there. Whoa, right? That's a lot of lines. But we know where our points are, so we don't have to worry about it too much. But right now, everything works just fine. Grab your ruler and I don't know, don't make it too small. And we kind of have to keep our time in mind. So I'm gonna, okay, so this is pork sandwiches. So there's pork sandwiches there, and there's hot dogs. And X, I'm gonna go to 700 there. So I'm just gonna quickly check here. 1, 2, 3, 4, 5, 6. I need 700 for sure, so I'm just going to make that work here. So now I can commit, right? 200, 400, 600. As long as I have that mark here for the 700, I'm good. And I need to go all the way up to 1500 at least. So 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's not going to work. So I'm going to go up by 300. 3, 6, 9, 12, 15. That's going to work for me. So every second line is 300 for me. All right. So let's plot those intercepts. 600, 0, 0, 1500 is right there. I'm going to go arrow out and just name this that. And we have 650, which is right there. 650 is right there. And 0, 650, this is so right about there. So they overlap a little bit, and I'm making a line from here. This is x plus y is less than or equal to 650. The tricky one here, it's this one, it's 0, 0. And I said that when x is 200, y is about 100, so it's right about there. So now you have, can you imagine if x had been 2, right? If you had picked 2 and 1, like good luck fitting that into your grid, right? So you need to pick bigger numbers, and then it'll be easier to work that out. Yikes. So this one, you can add an arrowhead to this one, because this one extends to the positives. So this line is the line y is less than or equal to 1/2 x. As I said, this is going to be the most work you're ever going to have to do. So I'd rather give you an example that's a bit tougher than too easy and then you're struggling with. So the other one is 400. 666, that would be just above it here. And so this line, I'm going to have a line going out of it, just saying that this is 2.5x plus 1.5y is greater than or equal to 1,000. Kind of looks scary, but one at a time. Okay, let's do the shading. So the first one, shade above. And I'm just going to lightly go over my labels so that I don't block them, right? Just go lightly over it, and then that'll do it for you. So that's gone. The second line, 650, this line right there, it's also shaded above. If you look at your notes, right? So everything above that is gone. Right? The third line, which is this one here, What does it say about that one? Before I do this, it's above as well. So you go like this. Everything above that is gone. So look what we have left, right? And then our third line, we're shading below, right? So this third line, I'm below it. So that's going to get rid of that little sliver down here, right? All of that is gone now. Do you know now why I used reverse shading? Can you imagine figuring out the correct region now, right? It's like, which one has all of the shadings in it, right? It'd be a nightmare. So solution is right there. How many corner points? 1, 2, 3, 4, 5. 5 corner points. So let's try that. POIs, I'm going to do the reading. The 400 0 is done. The 600 0, I got that. So I basically have to find these three using my calculator. Okay, so read. I know I'm giving you a workout today, right? Okay. You have to be very careful here. I'm going to show you how I do this. I don't take away anything. I'm just keeping like that. And I'm going to say, I want this one here. So I'm going to go second, trace 5. Uh-oh. I'm going to jump until I'm on this one here. Right? I'm right now on that one. So you just scroll back and forth until you see that you're on it, and then hit enter. This is not good. Can I, here, can you do this with me, please? Window, I'm going to go Y min. I'm going to go negative 20. I want to see a little bit more of Y min. And then hit graph again. Because it blocks a lot when you, let's see if this solves the problem. So I want this one right there. Second trace 5. Still does it. I want Y3, that one, enter. And then I want this one that I'm on right now, coincidentally. So enter, enter. So that point right there is 307.69, comma 153.85. This one up here, second trace 5. I want to jump on that line, enter, and then I want to be on the other one, right? If you go sideways, you can see which one you're traveling on. Hit enter, enter. So that's 433.33, 216.67. Sorry, one more. I want to find this one right here, which is this one right there on my screen. 2 seconds. Second trace 5. I'm on the line and I'm on the other line here. Enter, enter. So that's 566.67. 83 33. So if you're right now just writing this down, I encourage you to try that at home. And 1 second. What are we talking about here in this problem? What X represents pork sandwiches, hot dogs, right? You have to have whole numbers. So we round these. So this would be 308, 154. This would be 433, 217. This would be 567, 83. Right? Discrete data. That's very important to round your corner points. So homework, graph question 1 and question 4 on this piece of paper that we just worked through. Question 1 and 4, the POIs, everything, the whole thing. I have a picture, a color picture of my graph. Okay, so you'll see that. Yeah. It gets complicated. I'm just gonna tell you to just look at what comes after the decimal. If it's 5 or greater, then you just round up. What's that? Finding all these. You might have to practice that a bit more.